Hello everyone, today we will be learning about a topic from linear algebra, which is vectors and linear combinations. So to start off, what is a vector? A vector is a matrix with a single column. So basically, if we look at the bottom here, we have vector v, which has two entries. So we would say that it is a two-dimensional vector in R2. And we can look at a graphical representation of this here. So we see our first entry being 2, so that means we would move to the right horizontally 2 units. And then our second entry being 1, we would move up 1 unit. And that leads us to our point 2, 1. So there are two simple algebraic operations that we can perform on these vectors. The first one being scalar multiplication and the second one being vector addition. So first let's talk about scalar multiplication. So scalar multiplication is multiplying each entry of a vector by a scalar. And a scalar can be any real number. So looking at this, we have our vector v with the entries a and b, and we have our scalar c. So we would multiply c by each entry of our vector, which would be a and b. So we have c times vector v, and then we would have c times a, b. And we would multiply c by a first. So c times a is ca, and then multiply c times b, and c times b is cb. And that is our new vector multiple of ab. So one example that we can look at is use scalar multiplication to multiply vector v by scalar c, where vector v is equal to 2, 4, and c is equal to 3. So looking at this, we have c times v, and plugging in our scalar and our vector, we would have 3 times vector 2, 4. So we would first multiply 3 times 2 to get our first entry, and that is 6, and then multiply 3 times 4 to get our second entry, which is 12. So 6, 12 is our vector multiple of 2, 4. So now moving on to vector addition. So vector addition is adding two vectors of the same dimension by adding their entries. So basically what this means is we have vector v and vector w at the bottom. And we see vector v has two entries, a and b, and vector w has two entries as well, c and d. So what this means is they were both on R2. They are both two-dimensional. If one of these vectors had 3 entries and the other had 2, this would not work because they are not in the same dimension. So let's go ahead and add in vector v plus vector w, substituting in ab plus cd, and then adding our first row, which is a plus c, we would get a plus c, and then adding our second row, we would get b plus d. So the sum of vector v and w creates a new vector, which is a plus c and b plus d. So looking at an example of this, use vector addition to add the below two vectors. So we have vector v1, which is equal to 2, -4, and 3. And then we have vector w, which is -5, 6, and 7. So adding these together, let's go ahead and add our first row, which is 2 minus 5. We would get -3. -4 plus 6 is 2, and 3 plus 7 is 10. So the sum of vector v and w produces -3, 2, and 10. So now what is a linear combination of vectors? So a linear combination involves combining a set of vectors by multiplying each vector by a scalar and then adding the results together. So we can think of this as combining scalar multiplication and vector addition all into one expression. So for example, we would let v1, v2, and v3 be vectors. And we would let c1, c2, and c3 be scalars. In order to produce a linear combination of vectors, we would have to multiply c1 and v1 and then add that into the product of c2, v2 and add in the product of c3, v3. And what this would look like is we would have c1 times v1 plus c2 times v2 plus c3 times v3. And that is our linear combination. So looking at example number 3, if c1 and c2 are two scalars, then the vector c1e1 plus c2e2 is called a linear combination of the vectors e1 and e2. So find the vector that is a linear combination when c1 is equal to 3, c2 is equal to negative 4, e1 is equal to 1, 0, and e2 is equal to 0, 1. So we have our scalars and our vectors provided for us already. So we would follow the form c1e1 plus c2e2. So let's go ahead and plug in our scalars first. So c1 is 3 times e1, and then c2 is negative 4, so we would subtract 4 times e2. And then plugging in our vectors, we would get 3 times 1, 0, minus 4 times 0, 1. And we can show this. We would multiply 3 times 1 first, and then 3 times 0, and then subtract that from 4 times 0 and negative 4 times 1. And then we would get 3 and 0 minus 0 and 4. So our linear combination of vectors would equal to 3, negative 4.